We often treat mathematics like a foreign tongue. We assume it's external, a complex set of rules we force onto an empty mind. This idea traces back to the philosopher John Locke and his concept of the tabula rasa, or the blank slate. The assumption is, when we are born, our capacity for numbers is exactly like this image, a void, waiting for culture to fill it. But researchers tested this theory using infants who couldn't even speak yet. In what's known as the puppet study, scientists placed 2 puppets behind a screen, removed one, and then dropped the screen. If the screen revealed 2 puppets still sitting there, an impossible mathematical outcome, the infants stared significantly longer, showing physiological surprise. That prolonged stare suggests that these babies already expected 1 minus 1 to equal 0. Basic arithmetic logic operates in their brains months before they ever step foot in a classroom. This pre-verbal math extends far beyond humans. Honeybees can distinguish between displays containing 3 dots versus 4, and salamanders consistently choose the tube containing more fruit flies, calculating the optimal meal without any formal training. The evidence suggests the blank slate is a scientific impossibility. We arrive in the world with a cognitive ledger that already has numbers written into it. The biological mechanism driving this is called subitizing. It's the brain's ability to instantly recognize small quantities, under 5, as a single holistic shape. When you see 2, 3, or 4 dots, you don't count them, you just know. However, there is a hard limit to this hardware. Once a cluster hits 5 or more items, the instant recognition fails. We hit a biological bottleneck, and the brain switches gears to manually count the objects one by one. This specific 4-item limit evolved for a practical reason. For early human ancestors, scanning a bush and instantly recognizing the exact density of berries, 3 here, 4 there, meant acquiring food efficiently while keeping an eye out for predators. Counting is a much slower secondary process. It requires working memory and language, leaning on different, more recently evolved networks in the brain. Slowing down slightly. Subitizing is the irreducible building block of our numerical reality. It is the biological atom from which all higher mathematics is eventually built. Inquisitive. Since we possess these built-in mathematical instincts, we have to ask, where exactly is the physical hard drive located inside the skull? Neuroscientists have mapped it to a deep fold in the parietal lobe called the intraparietal sulcus, or IPS. Located near the top back of the head, this specific trench acts as the brain's dedicated number command center. The IPS reacts to more than just digits. It fires for anything involving spatial magnitude. If you judge the length of a line, the size of a circle, or process the number 7, this exact same region activates. Because numbers are mapped alongside physical space, some people experience a phenomenon called number form. They see numbers arranged in specific 3-dimensional architectures floating in their mind's eye. The IPS proves that math is a physical structure woven into our neurobiology, as concrete and measurable as a lung or a heart. We can see the stark reality of this physical structure by looking at what happens when it doesn't develop typically. This leads to a condition known as dyscalculia. Someone with dyscalculia might have high intelligence, exceptional reading skills, and sharp logic, but their intuitive number sense is functionally absent. Looking at the numbers 8 and 6, they cannot immediately perceive which is larger without manually counting up from 1, experiencing a numerical void similar to this blank page. Functional MRI scans confirm exactly why this happens. Individuals with severe dyscalculia show significantly less gray matter density, specifically within the intraparietal sulcus. These physical density variations provide a medical explanation for math difficulty that often has nothing to do with a student's effort. Standard education frequently fails these students because it relies heavily on rote memorization. This approach ignores their biological need to process numbers spatially and visually. Acknowledging the precise biology of the mathematical brain is the necessary first step toward building a more adaptable, empathetic education system. We started with the idea of a blank slate, but the physical evidence leads directly to the specialized folds of the intraparietal sulcus. If we know the brain processes numbers as physical magnitudes, we can teach mathematics through spatial play, using blocks, visual models, and geometry. We can align the classroom with our biological strengths. This biological module allows us to treat the blank page as a workspace for visual, instinct-based mathematics. You aren't bad at math. You simply have a specialized neural architecture waiting for the specific spatial logic it was designed to process.